For lesson 2.2, we're still going to be working with a quadratic function, but this time it's going to be in what we call standard form. It's probably the form you've most likely seen a parabola given to you in, and it is this, ax squared plus bx plus c. We worked with vertex form in the last section, and that helped us find a key feature, especially the vertex, but now we're going to be finding key features from the standard form. Example 1 would walk you through how to find the vertex from any standard form. I'll use these same steps in the next example, but you can sure check your teacher's example or answer key to find these steps and fill in your packet. Same thing goes for the try it. You'd want to find your key features. One note is in your packet, this second equal sign should be a minus. So if you're trying to try it by yourself, that little typo there should be a minus. But again, I will employ these same tactics that want to find the vertex in standard form in example 2. So we're going to start with, we want to find this equation here, x squared minus 4x plus 8. We eventually want to graph it, but we want to find the vertex. So in example 1, they would have walked you through this process. Our first goal is to do the formula x equals opposite b over 2a. Now I say opposite because it doesn't mean this negative sign is always going to be included on the top of your fraction. This will give us the x coordinate of the vertex. Now, let's try that with our equation down here. So we have x squared minus 4x. Our b value is right here. It's a negative 4. We don't include the x with it. So we would write x equals, we're going to change our negative 4 to a positive 4 because the equation for the x coordinate of the vertex wants the opposite of what you already have. So if you see a negative 4 here, you'd put a positive 4. If this would have been, say, plus 6x, you would have put a minus 6 up here. All divided by 2 times your a value. Our a value is right here. We don't see it, but it's our 1. And if I would simplify this, 4 over 2 makes 2. This is our x coordinate of the vertex. So over here I'm going to write 2, comma, and be waiting for that y value. To find the y value, you need to take that x of 2 and plug it in to your original equation. So I would have y equals 2 squared minus 4 times 2 plus 8, which comes out to 4. And that will be my y value of the vertex. So I could go ahead and plot that on my graph over here at x is 2, y is 4. Now the axis of symmetry is the line where you would cut right down the middle of the parabola. Think about any parabola. If I draw one up here, if you had to cut that and it was a perfectly drawn parabola, you'd cut it right down the middle. You should go through that vertex. So wherever your vertex is plotted, which it is on my screen over here, this would be my line of symmetry. This cuts through that vertex. So my line of symmetry or axis of symmetry is the same as the x coordinate of my vertex, and that will always be true. Now my y-intercept. Standard form is the best to find the y-intercept. If you just looked at this beginning red boxed equation, we should be able to find the y-intercept without doing any math. Remember, a y-intercept is this last c value, if you will. That's because if you made x be 0 in each of these other cases, that'd make you be on the y-axis. 0 minus 0 plus 8 is 8. So we'll put our y-intercept is 8, and I'll go ahead and plot that on the graph. Let's look if this parabola opens up or down. We talked in section 2.1 how your a value determines that. So when it's just a positive 1x squared here, I know it's going to be this happy parabola. So I'm going to start connecting these 2 points here. And I know that's my vertex, and that'd be the turnaround. I want to come back up here. Well, parabolas are nice and balanced, and we know that's the case. So if I want to make this balanced as it is on the left, the same as the right, I would put another dot here. That's simply how we're going to find this last point here. I will graph 4, 8, which I got from this blue dot over here because it was a mirror or a balance from my vertex off the y-intercept. So I could now continue my parabola, and I have the sketch. Again, we know it opened upward. We knew our line of symmetry and our vertex from our box right here, and I got this last point by creating a mirror over that line of symmetry. This is how you would want to sketch any standard form quadratic function using the key points. So let's look in a little bit of a speed mode here at our triad. My y-intercept would be -1. And to find the vertex, we're going to use this formula to find our x part of the vertex. So since my b is a -6, I don't leave it negative, I change the opposite of my b. So it will be x equals 6 over 2 times my 1, because I don't see a number there, so it's 1. And 6 divided by 2 is 3. So I know my vertex has an x coordinate of 3, but I want to find that y value. And in order to do that, I will plug in this 3 into my equation where I see x. So I'd have 3 squared minus 6 times 3 minus 1 to get my y value. That'd be 9 minus 18 minus 1, which would equal -10. So that would be my y value of my vertex. I'll go plot 3, -10 on my graph. I know that my line of symmetry always cuts through the vertex, so I'll try to sketch it here. And if that was my mirror and it needed to be balanced, it was 3 steps over here to this y-intercept at -1. So I'll go 3 steps to the right and have this y value of -1. That coordinate is 6, -1 now, in case you're wondering. And I could connect that parabola, and I have my new graph. As for application, again, why do we learn the math we learn? There can be profit models, such as the one they talk about in example 3, and they graph it, lots of big numbers, but they want to know what's the maximum profit they can expect to earn. So I have a graph here. I would say a max profit, since profit is what they're measuring on the y-axis. I want to be up as high as I can. So I'm basically looking for this top point. So if I wanted to find that max profit, I am going to need to know the vertex. So to find the vertex of any parabola, I will use x equals opposite of b. So here's my b value, -700. All divided by 2 times my a value, which is -10. And I'd solve that. So I'd have x equals 35. Now remember, that refers to my x coordinate. I want to find the y. So I would need to take that 35 and plug it into each coordinate where x is in the equation. And that would give me y equals -10 times 35 squared plus 700 times 35 minus 6,000. If I were to do that, I'm just going to use my calculator here. I get 6,250. That's the y value for how high this is. That would be my max profit that they earned. You can try this one and your triad and check out your teacher's answer key if you need more practice.